guys. I am sorry I can't be with you today, but your substitute here is going to operate the smartboard, and you are going to take notes on this packet that you should have in front of you right now, and you will kind of follow along with me as we take notes, and there will be different times when the sub will pause the video, and you will work on some things on your own to see if you're getting it. All right, so this section we're going to talk about several different things. We've got quite a big lesson here for today for you. We're going to talk about compound inequalities and what those are. And then we're going to look at different ways to write our answers to inequality problems that you've been doing. So far, you've been writing all your answers with the less than and the greater than and so on symbols. But there are actually two other ways we can write our answers that you'll see in your higher level math classes. And so we're here to get you ready for that. All right, but first a little warm up. Here we have two statements in words. All real numbers that are less than or equal to 8, and all real numbers that are greater than -7. I want you to graph, let's call this one A and this one B. Let's go ahead and graph those on these number lines, and then can you write those using your inequality notation over here where it says as symbols. And for all real numbers, you can just use an X or an N, whatever your favorite variable is. And go ahead and do that. Substitute, please hit pause. All right, so let's see how you did. Okay, check there and see. How did you do on those? Did you get them right? If you need to, ask the sub to hit pause so you can ask a question or talk about it with a group member. If not, we're going to keep on going. That should have been a review of what we've done so far. But now look at this next problem. It's a little bit different. It's got more to it. It says all real numbers that are less than or equal to 8 and greater than -7. So let's see what that would look like on our number line. We know how to do less than or equal to 8. Less than or equal to 8, remember we'd have a solid circle because it says or equal to, and it would be everything to the left, right, for less than or equal to 8. But then we have greater than -7. Well, -7 is right here, and it just says greater than, so that would be an open circle. And we want greater than that, so that would be everything from here on up. So if it has to be the blue and the red interval at the same time, well, really then we're just talking about where they overlap, right? So everywhere between here and here is where the red and the blue overlap. So that is the graph of this expression in words. So to clean that up a little bit, I'm going to erase that. And so if we went less than or equal to 8 and greater than -7, we're wanting everything in between there. So that's what that graph looks like. How can we write that in inequality form? Go ahead and take a second and see if you know how you would write that. Did you write it like this? Think of X as everything between two numbers, right? So what's this between? It's between a -7 and an 8, right? So I write it between -7 and 8, and then I pick the right symbols. It was less than or equal to 8, right? So that's what we do. But it's greater than -7. So if x is bigger than 7, remember, we have to have the open part. The alligator mouth, as you guys were telling me, is going to the x because it's bigger or greater than -7. So that's what this would look like. And that's called a compound inequality because it's showing two inequalities basically put together, compounded together. Okay? So this type of compound inequality has a special name. It's called an intersection. And that should make sense. It's because it's where our two graphs that I did above when I had them in blue and red, it's where they intersected. Okay? Sometimes we'll refer to that as an and problem. Because in words up here, we had less than or equal to 8 and greater than -7. So the official name is an intersection, but sometimes just to be casual, we'll call it an and problem to make sure we're all on the same page. Okay? All right, so then next, what do we've got? We've got all real numbers that are less than or equal to 9 and greater than or equal to 0. What I want you to do is write two separate inequalities in this box, break it down to two separate inequalities, and then combine them into a compounded inequality here, and then make a sketch. Substitute, please hit pause while the students do that, and hit play again as soon as they're done. All right, so check your answers there that just popped up. Is that what you did? X is less than or equal to 9, and X is greater than or equal to 0. As a compound inequality, this is what it looks like. And on the graph, it's all these numbers between and including 0 and 9 because it said or equal to, so we do solid circles there. All right? Again, if you need questions, just ask the sub to hit pause, and you can ask each other questions, or maybe the sub can help you out as well. Okay? When you're ready, go on. Hit play. All right, so now we have some more here. I want you just to practice, okay? So let's go ahead and do these next two examples on your own. See if you can graph them and write them as a compound inequality on these lines right here. Okay, substitute, please hit pause. All right, so check your answers there. N is greater than 0 and less than 8, so that's all these numbers between 0 and 8, but then notice they are open circles here because we're not including those endpoints, okay? And on this one down here, we've got K is greater than or equal to -7 and less than or equal to 5, so that's all numbers between -7 and 5 here on our graph. Notice the solid circles. Make sure you have solid circles because this time, because of these equal signs, we are including those endpoints there. Okay? All right, now let's go backwards. You have the graph. I want you to write the compound inequality. Substitute, please hit pause while they do that. All right, check your answers to that and see if you got them correct. In the first one, x is greater than or equal to -5 and less than or equal to 4. On the second one, x is just greater than -8 and less than or equal to 9. Okay? So you guys, probably a good idea, if there's any of this you don't understand, I know it's tough since I'm not there, and I don't know if your substitute has got a good math background with this stuff or not. So if there's something the sub can't answer for you, please just write it down on your paper, so when I come back on Friday, you'll have those questions. You won't have forgotten what your questions were, and we can go over them. Okay? That would be best. All right, turn the page. Okay? Now it's a little bit different type of problem. This one says all real numbers that are less than -4 or greater than 2, okay? Less than -4 or greater than 2. So let's see if we can write those in inequality form. Numbers that are less than -4, so x less than -4, or greater than 2, x greater than 2. And remember, it doesn't matter what variable, pick your favorite letter, okay? I'm just using x this time. All right, so how can we combine that? Let's think about it. Go ahead and graph. Let's graph both of these on these two number lines, okay? X less than -4. So -4 is right here. We're less than that, so that's all the numbers to the left. So that's those, right? Open circle because it's just less than. Then we've got x greater than 2. Okay, well, there's 2. It's greater than, so it's an open circle. Numbers bigger than 2 are to the right, so it's to the right, right? Is there any overlap there? There's not. They don't overlap, but we're saying we want any x number that's here in this interval, change colors, so here or here, so it can be any of those numbers. So we really just want those together. So we're saying we want these numbers or we want these numbers. So when we graph this situation up here, we actually put both of those graphs together on one. So this is the actual graph of the compound inequality. Well, how do we write that? We can't write them together as one statement like we did on the previous page. These are two separate sections, right? They're not one section, they're two separate, so we have to keep them separate. So x less than -4, we're going to write that again. And then we have a fancy math symbol we call the union. Okay, so we can use that. Actually, let me save that for later. Let's go ahead and just write or x greater than 2. So we can't write those together. We can't put them together. There's no way we can change how it was. There's no way to combine them, okay? We can't combine them together. All right? What is this called? This called, when we put these two graphs together, that's called the union of these two inequalities, or the union of these two sets, okay? And we'll sometimes refer to it as the or problem. Because again, these types of problems always say or, whereas the other ones we did before were and. Okay? All right, you guys, I want you to go and see if you can graph these inequalities. These next two, go ahead and see if you can graph these on a number line, just like we did up above. Okay? You're just graphing the final product. So this particular situation up here, this was the actual graph of these inequalities. Okay? So I want you to make graphs of these two sets of compound inequalities and then go backwards on these final two with these graphs here and here. Write the inequalities for those. Okay? Substitute, please hit pause. All right, check your answers there. Check your graphs. Being careful to note the open circles and the closed circles. Make sure you get those correct. And then on your inequalities that you wrote, being sure to note that these here are strictly less than and greater than, whereas on this one, this is a less than or equal to, and this one is just a greater than because of the open and the closed circles. So make a note of that. Again, if you need to, ask some questions before moving on. Okay, whenever you're ready, let's go ahead then and turn the page, the next page. What we're going to look at next is another way. Remember I told you at the beginning we're going to look at another way of writing our answers. And one of those ways is called set or notation. And really, I don't want you to stress about it because it's really not all that different than what we're doing. We're just putting some more fancy stuff around our inequality answer. So looking at these examples here that I have written on the page, if your solution, if you solve an inequality and you get x is greater than 5, set builder notation looks like this. Notice we've got the curly brackets on either end, and we have an x, and then a vertical line right after it, and then our inequality x greater than 5. So the only thing that's different is the curly brackets, and then we've got an x in front and then a vertical line there before writing x greater than 5. Okay? How do we read that? What does that mean? Well, the way we read that is the set of all numbers x. So that's what that first part means. When we say the set, that's what these brackets mean. The set of all numbers x. That's that first x. All numbers x such that. The vertical line means such that in mathematics. X is greater than 5, which is that next statement right there. Okay? So the set of all numbers x such that x is greater than 5. I know you're probably thinking, why would we write that? Why can't we just write it like that? Well, in Algebra 1, most of the time, that is how we're going to write it. But, again, we're always preparing you guys for what comes next. I know several of you want to go on and become math education majors or math majors in college, and you need to know some of this more sophisticated notation so when you get there, you're not clueless. Okay? So we're just going to show you a little bit of it here today. All right, looking at another example, x less than or equal to -4. We just write the set brackets and say x such that x is less than or equal to 4, or the set of all numbers x such that x is less than or equal to 4. Okay? Look at this next one. It's kind of weird. Notice this is an and problem, so remember we'd be looking for the overlap. So x is greater than 2 and x is less than 0. Let's think about that on a number line. 0, 1, 2. If x is greater than 2, that's all those numbers, right? If x is less than 0, that's all those numbers, right? There's no overlap there. You can't be up here and down here at the same time. So that means there's no solution. Well, no solution in set builder notation is just what we call the empty set, which is these two curly brackets there with nothing inside of it. Okay? That means the empty set or no solution. Okay? Now let's look at kind of the opposite situation. We have x is greater than -2 or x is less than 1. So -2, -1, 0, 1, 2. Okay, quick little number line. X greater than -2. Well, where's that at? Greater than -2 are all these numbers, right? X less than 1. X less than 1 are all these numbers. Okay? So, or remember, is when we just join the two sets, we put them together. It's the union, okay? Well, if we put these two together, aren't we actually including the whole number line? If we look everywhere there's blue and red, that's the whole number line because the red goes forever to the right and the blue goes forever to the left. That's all real numbers. How do we write that? Right here. We read that as the set of all numbers x, such that x is any real number. This little symbol here actually has a formal name. It means the element of. So we say x is an element of the real numbers. That means it's a member of that set. Again, it goes with this set builder notation. So all numbers x such that x is an element of the real numbers. And what that means, that corresponds to a phrase we've used before called infinitely many solutions. It means there's many, many, many solutions. You can't even write them all down. All real numbers are a solution to this inequality. Okay? All right, so I want you to take a couple minutes. The sub is going to hit pause here in just a second, and I want you to fill in the empty squares for these next three examples. Okay? Substitute, hit pause, please. All right, check your answers there. That should have just popped up, and see how you did. Give you a couple seconds to kind of look over those. All right, if you need more time, just ask the sub to hit pause for a little bit so you can go over those more. All right, so that was set builder notation. Now we're going to look at one other way to write your answers. And this one is actually, the set builder notation you probably wouldn't really see till college, I think. Maybe a little bit in Algebra 2, but it's really not used that much in high school. Interval notation, however, is used in Algebra 2, pre-calculus, and then you'd use it in college as well. So another way to write the answer to an inequality is with what we call interval notation. So that's what we're going to look at next. Okay? All right, so let's say we have this inequality, x is less than 3. We all know how to graph that, right? And in fact, you know how to graph all of these now. So would you go ahead and graph those 4 on the number line, and then we'll come back and we'll talk about how to put those in interval notation. So substitute, please hit pause while they do those graphs. All right, check your graphs real quick. Look over those, make sure you made those graphs correctly. If not, ask the sub to hit pause for a minute so you can try to clarify. Maybe he or she can kind of clarify you where you went wrong, or maybe your partners at your table can. Okay? So interval notation. All right, let's think about this. If this arrow here on this first problem is going on forever, where is it headed to? That's kind of a weird question, right? It's headed down into all these negative numbers. It's going to keep getting more and more negative, right? Further, 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 further. So what's its destination? It's going to keep going, but what's it approaching? Anybody know? Shout it out. Did you say negative infinity? If you did, you are right. So if you think of looking at this graph, we want to look at this graph and say, what's the left-hand boundary of it and what's the right-hand boundary of it? This first graph's left-hand boundary, it's heading down here to negative infinity. So for interval notation, we're going to do a little parenthesis, and then we're going to put a negative infinity and then a comma. And what that negative infinity is the left-hand boundary of our shaded area on the number line. Okay? What's the right-hand boundary? Well, the right-hand boundary actually stops, right? Where does it stop? It stops at 3. So we put a 3 there. Now, we do need to be able to tell the difference between if it's an open interval or a closed. This one's open. We use a parenthesis for open interval, okay? Notice I chose a parenthesis for negative infinity because we can never actually get to negative infinity. It's a destination you never get to. You just keep approaching it. So that's why we got a parenthesis there, because it's an open interval as well. All right, and that's called interval notation. When you use this, we know you mean all x values between negative infinity and 3 are the solution. Okay? The next one, all right, think again about what's shaded on the graph. What's the left-hand boundary? Well, the left-hand boundary is a 1, right? Are we including the 1 or not including it? We're including it, so it's a closed interval. To denote that that's a closed, that we're actually including the 1, we use a square bracket. Okay? Put the comma. What's the right-hand boundary on this graph here? What's the right-hand edge? Where is it heading? It's an arrow, so that means it's going to keep going forever. Where's it headed? You said it, positive infinity. And again, we use a parenthesis there because that's not, it won't ever actually get to positive infinity. It's heading there. Infinity always gets in a parenthesis, an open interval notation. Okay? All right, this next one. All right, again, looking at what's shaded. What's the left-hand boundary of what's shaded? It's a -2. Is it included? Yes, it's a closed circle, so we put a square bracket. Comma. What's the right-hand boundary of this shaded area on the number line? It's a 3. Is the 3 included? No, it's an open interval, so we do a parenthesis. So that's interval notation for that solution. Okay? And then the last one. Okay, this one's a little different because our shaded area is in 2 chunks, right? 2 chunks. This one up here, the third one, was what we called an intersection. This is what we call a union, okay? So we're going to just write it in 2 pieces. So this first piece, we always start left to right. What's its left-hand boundary? Hopefully you said negative infinity. What's the right-hand boundary of this first chunk? It ends at 0. Are we including 0? No. So parenthesis, okay? Then we start another one. Our next interval now, this next chunk of our graph, what's its left-hand boundary? It starts there at 1. Are we including 1? Yes, it's a solid circle, so we put a square bracket. Comma, what's the right-hand boundary? Infinity, because it goes forever, so positive infinity with an open bracket. Okay? So we want to say that our solution can be anywhere in this interval or this interval. Remember, we called that a union. There's a special math symbol for or. You could write the word or in there if you wanted, but the special math symbol, if you want to be more sophisticated, is like a capital U. That means union. Okay, so that would be the solution to the fourth inequality. All right, so substitute, please hit pause while my students try to do the rest of the problems on this page. On this section, you're just writing them in interval notation. That's all you have to do. No graph is necessary. But then down here in this table, I want you to do the graph if it needs to be done and write the interval notation if it needs to be done. Basically, you've got 3 squares to fill in for each problem. Fill in the 2 missing, the 2 squares that don't have anything in them yet. Okay, substitute, please hit pause while the students do this. All right, guys, go ahead and check your answers there to those problems. Again, I'm going to have the substitute hit pause while you do that. Sub, please hit pause now while they check their answers, and then go ahead and hit play when they're ready to go on to the last page. All right, so stay with me, kids. I know this is a long lesson, but you're almost there. We're almost home free. All right, one more thing. Look at this problem, okay? So we've seen answers where we had x between 2 numbers, but now we've actually got an expression in there between 2 numbers using the inequality systems. And we want to solve for the x that makes that compound inequality true, okay? It might look really ugly, but never fear. All we're going to do is we're going to split it into 2 problems, okay? I'm going to first pretend that all I see is that problem. 5 is greater than x minus 2, right? That has to be true, okay? So I'm going to go ahead and solve that. You guys know how. Add 2 to both sides. What do I get? I get 7 is greater than x, right? Or I like to always put my variable first. If 7 is bigger than x, that means x is less than 7, right? Okay, so that's one part of the solution. Now I'm going to do this. I'm only going to look at this part of the problem. But since this was a compound inequality, is this, in this form, is this an and problem or an or problem? It's all together, right? So it's an and problem. So over here, 5 greater than x minus 2 had to be true, and this other inequality has to be true, x minus 2 greater than negative 2. They both have to be true. So now I just solve this one, and I get add 2 to both sides. What do I get? I get x greater than 0. So my solution then is that x has to be less than 7 and x has to be greater than 0. Okay, so let's think about how that looks on the graph. Okay, just think visually here. If this is 0, 1, 2, 3, 4, 5, 6, 7, x is less than 7, so that's all the numbers from here on down. And then if x is greater than 0, that's the numbers from here on up. So that's an overlap. So we can write that as a compound inequality, right? And say x is bigger than 0 and less than 7. Or in other words, x is between 0 and 7. And that is our solution. So any value x that's between 0 and 7, you could plug in to this original inequality and you'd get a true statement. Okay, so it's just taking it and breaking it into 2 parts. I'm going to do one more together with you, and then I'm going to let you try the rest on your own. Okay? So this one, we're going to split it into 2 pieces. So negative 9 less than or equal to g plus 7. That has to be true, and g plus 7 has to be less than 12. Okay? Solve each one. You can do this. Subtract 7 from both sides. What do we get? I get negative 16 is less than or equal to g. And I'm going to have to solve this other one. Subtract 7 from both sides. Please cancel. So I get g is less than 5. So g is, remember, negative 16 being less than or equal to g means g is greater than or equal to negative 16, right? So you can think of it either way. So I'm bigger than a negative 16, but also less than 5. That, again, is an intersection. That's an overlap, so I can write that together. Different color here. So g must be bigger than or equal to negative 16, but at the same time, less than 5. So you're really just putting this answer and this answer together into this compound inequality here. So any number g that's between those 2 numbers is going to make this statement true. Okay? I'm going to jump down here and do number 3 with you, and then you're going to do 2 and 4 on your own. Okay? All right, so here now notice this is an or problem. That actually makes it even easier because the two problems are already divided for you. So negative 20 is greater than 5j. Divide both sides by 5, right, to get j by itself. Those cancel. So I have a j over here. And on the left-hand side, negative 20 divided by 5 is negative 4. So negative 4 is greater than j, or if you like to put the letter first, j is less than a negative 4. Or this one has to be true. Negative 17 plus 2j has to be bigger than negative 7. You got to do two steps now. I have to add 17 to both sides first. When I do that, those cancel. So I just have 2j greater than negative 7 plus 17 is positive 10. Divide both sides by 2. Cancel. We get j is greater than 5. Okay? So j is less than negative 4, or j is greater than 5. Do those overlap? Can I put them in together, like an inequality like this? Or are they two separate sets? If you're less than negative 4 or you're bigger than 5, you can't be both at the same time. It's an or problem. It's not an and problem. So that is our solution. Okay? If we wanted to write that in interval notation, j less than negative 4, that would be from negative infinity to negative 4, union with 5 to infinity. Okay? It would look like that. If we wanted to go back here and do interval notation for this one, it would just be negative 16 using a square bracket because it's the less than or equal to, and then comma 5 with an open bracket because this was strictly less than there. Okay? All right, so we're almost done. Do those last two examples. Substitute, please hit pause one last time, and when they're done, hit play so that they can check their answers, and then they'll be good. All right, so here are your answers right over here. Go ahead and check them. I didn't show all the work because I know you guys know what you're doing here. So you might have written your answer in inequality form, or if you wrote it in interval notation, it would look like that. 1 to 15, square brackets, because both of those inequality signs had less than or equal to on them. Okay, for number 4, your solution should have been y is greater than greater than or equal to 9, or y is less than negative 2. In interval notation, that would be what your answer looks like. Okay? I know this was a lot today, guys. I really hope you've been great for the sub. Hopefully he leaves me or she leaves me a good report. Do the best you can. Now you have a practice worksheet to work on that the sub will hand you out. Do your best on it. Use these notes. These notes have everything you need to do those problems, and I know you can do it if you guys work together. Okay, so you have the rest of the hour to work on that worksheet. If you get it done, hand it into the sub before you go. If you don't get it done, try to finish that worksheet up for homework. All right? Thank you very much. I hope you're having a great day. Bye.